This question asks us to draw the molecular orbital picture for but2-ine. The two carbons on the end are sp3 hybridized, which means they're tetrahedral in geometry. They're comprised of 4 sp3 hybridized orbitals pointed towards the corners of a tetrahedron. The two internal carbons are sp hybridized, which means they have a linear geometry. They're comprised of 2 sp orbitals oriented 180 degrees opposed from each other, and 2 unhybridized p orbitals that compose the pi bonds of the alkyne. I'm going to start with the in the plane groups first, and I'm going to draw this in a perspective drawing where I'm assuming that the plane is going to be perpendicular to the board. So bear with me as I draw it. By the time we're done, I'll show you what I'm trying to draw. So I'm going to start with the carbon on the left. It is a carbon. It is going to be bonded to one hydrogen in the plane. Again, this plane is assumed to be perpendicular to the board. And has another in the plane sp3 hybridized orbital bonded to the carbon of the alkyne through a sigma bond. This is our first sp hybridized orbital for the sp hybridized carbon of the alkyne. There are 2 other hydrogens. I'm going to draw those in a minute. This carbon of the alkyne is sp hybridized, so one sp hybridized orbital in one direction, the other sp hybridized orbital 180 degrees opposed. That one is bonded through a sigma bond to the other carbon. This third carbon is sp hybridized, one sp orbital comprised half the sigma bond, and the other sp orbital is 180 degrees opposed, and it is bonded through a sigma bond to carbon number 4. Carbon number 4 is sp3 hybridized, so it's using an sp3 hybridized orbital, another sp3 hybridized orbital to bond to hydrogen. All of these are in the plane of are in the same plane. All of these atoms are coplanar, and that plane is assumed to be perpendicular to the screen. In fact, let's go ahead and draw in that plane now. It will be something like this. Where this plane is assumed to be perpendicular to the screen, where this part back here is further away from you and this part is closer to you as the viewer. The carbon atom on the left has a hydrogen that's sticking up out of the plane and one going down into the plane. So one hydrogen is up and it's bonded to a hydrogen, and one bond is down and it is bonded to the other hydrogen. Same is true for this carbon on the right, carbon number 4. It has one hydrogen that's sticking out up above the plane, bonded to a hydrogen, and one bond that's sticking down below the plane that's also bonded to a hydrogen. The 2 sp hybridized carbons have 2 unhybridized p orbitals that comprise the pi bonds between the 2 carbons. One of those pi bonds sticks up and down below the plane. And the other pi bond is in this plane, is perpendicular to this screen. So they'll have one lobe coming out this way and one lobe going back this way. So our 2 pi bonds of the alkyne, there's one pi bond here and one pi bond here. This would be the molecular orbital picture for but2-ine.